Okay, 8.1 is integration, and we've done pretty much all of 8.1, even though you don't know it because it talks about different integration methods. 8.2, however, is integration by parts. And there's a formula, and this is the formula. The integral of u dv is equal to uv minus the integral of v du. So basically what's going to happen is you're given this and you break it down to what's in green here. The reason being is that maybe you could break it down to v du so where that you can do that. So let's look at this problem here, and I think you'll see stuff to go. Now I'm going to set u equal to x. So therefore dv is equal to e to the x dx. So now if I wanted to get v, I integrate both sides. So that's the first thing you're going to have to do, is when you get dv, you integrate both sides, but it turns out nicely that v is e to the x also. Du turns out to be the derivative of u, which is just 1 dx. So here's the deal. The two things in red I pulled out of this. I said u is x, then I took the derivative to get 1 dx, and then I took this as dv, all that, and then what I did was take the integral to get v. Okay? So according to our formula, it's going to be u times v. So it's going to be x times e to the x minus the integral of v times du, which is dx. And now I can do this problem right here. That problem I can do, and I know the answer to, and so do you. So it's going to be equals x e to the x minus, and remember this was u times v minus the integral of v, get out of there, v du. So that's where this all came from. And now it's just going to be this minus, well, what's the integral of e to the x dx? Just e to the x. So this is just e to the x. That's it. So I'm going to get this plus c. So that is the answer to this all the way up there. It is that. Sometimes in some books they'll factor out an e to the x. So you'll get x minus 1 plus c. Done. Okay? So we're taking u, we got u dv, and from there we got v du. Perfect. Let's do another one. Got another one here. Alright? I'm going to set u equal to the ln of x. Therefore du is 1 over x. How did I get that? I just took the derivative. Then I'm going to say that this, and this is dv. So I have dv to be x squared dx. Now to get v, I'm going to integrate both of them, and v turns out to be x cubed divided by 3. So now the formula says this guy is equal to uv. So it's going to be uv minus v du. So let's plug and play here. So this is going to be u times v, which is just going to be the natural log of x cubed all over 3 minus the integral of v, which is something we can do, times du, which is 1 over x. And actually, I forget to do this sometimes, but this is dx. So this is dx. I could work this out. This is x cubed ln of x over 3 minus, this turns out to be 1/3. I'll bring the 1/3 out, and this is x squared dx. Now I can do this. I know what that is. So this is going to be x cubed ln of x to the 3rd minus x cubed over 9 plus c. If you wanted to get it to put it all together, we could put it all together. Okay? But this turns out to be your answer. That is the integral of what's here in blue. using that formula. So a question has to come up. Why am I choosing U all over the place? Well, there's this Marashio way of choosing U, okay? And it's Italian, and it's called liate, okay? L, this is the order of which you would choose U. So if there's logs present, that's what U is. If there's inverses, then that would be the U. Algebra, like x squared, x, things like that, you pick that as U. Trig, and then exponents are last. So that's why in the problems before, the algebra was before the E, and the natural log was the U here. So this is fantastic. Now, oh, I guess I didn't erase this, but let's do this. Okay, we can do this. Let's undo this. So here we go. We got x squared times sine x. And I'm sorry, I forgot. We're going to erase homework too. What the hell? Get rid of it. So now we have x squared times sine x dx. U is the algebra, which is before trig. So I got u equal to x squared. Du is 2x dx. And dv is now sine of x dx. Therefore, v is, take the integral of both sides, v turns out to be negative sine, negative cosine, I mean, of x. So, I'm going to rewrite this. It's going to be this, x squared sine dx equals u times v. So it's going to be negative x squared cosine x minus the integral of v du. So v is negative cosine x. That's v. And then du is times 2x dx. Well, I got a little bit of a problem here. Okay? Got a little bit of a problem, and that's I don't know how to find the integral of this thing. I could bring that negative out and make it nice. Okay, I could bring that interval out. Come over here. All right, and make it nice. I haven't looked up in a while. It's because it's very loud in this library. You would think a library is where it's supposed to be quiet. Me too. All right, plus cosine of x times 2x dx. Well, guess what? I'm going to have to do it again. So I'm going to do it in blue. So I'm going to have to figure this guy out. And I'm going to have to do integration by parts again. So this is a double integration by parts. So this is going to be u is equal to 2x. So du is 2 dx. And then dv is that stuff. dv turns out to be cosine dx. So if I take the integral of both sides, I get v equal to sine of x dx. I forgot cosine of x dx. There it is. So now I'm going to take this part and do a integration by parts and say this is v times u, or 2x sine of x, minus integral of v du. So now this is 2 sine of x dx. I put the 2 out in front. So now I have this stuff which is unchanged. All right, I didn't change any of this stuff. Sine of x dx equals this thing, which is negative x squared cosine x plus, that's the plus, and now I change this. So now this is something I can do, all right, and I'm going to do it in black. So this guy just becomes, when I do that integral, minus, remember that minus stays, so it's going to be minus 2 times negative cosine x. That's what that is. So it's going to be this, which is my original. That's the original. Equals negative x squared cosine x plus 2x sine x minus, this is actually going to be a plus. I'm going to make this guy red. Don't blink at all. This is going to be plus 2 cosine x plus c. This turns out to be my answer. Alright? So we had to do it twice. That's the big deal about this one. We went through it twice. There's one more I'd like to show you. Alright, this is my last problem. I gotta go to ShopRite tonight. I really hate ShopRite. If there's anything in my life that I really hate, it's ShopRite. Because I just don't. Alright, this is a secant cubed. And that's equal to secant squared secant. I don't know if you'd think about doing it like that. Alright. Maybe you would, maybe you wouldn't. But now I'm going to set u equal to secant of x. Therefore, du is secant x tangent x dx. dv turns into the integral of secant squared x dx. So this is my dv, if you will. So now, oh, no, I don't want this here. I don't want it there. There it is, it's gone. So now I'm going to get v. So v equals tangent of x. So now I'm going to make this the secant cubed of x is equal to uv, secant x tangent x, minus the integral of v du, tangent of x du, which is secant x tangent x dx. Oh my God, I'm going to show you something that you're not going to dig. You will not dig this, okay? But you know what? If I show it to you once, maybe, just maybe, you'll see it again sometime. And that's the tangent squared of x, secant of x dx. This has a trig identity. Trig identity. All right? In the trig identity, all right, this guy becomes secant squared of x minus 1. So I have for this part secant x minus 1 times secant of x dx. All right? So now this is going to be really the same as negative secant cubed of x minus secant of x dx. Well, wait a minute. If I'm right, this guy, what I can do is something a little crazy. I can add this. There's a big equation. I can add that to that side. So I get the following. 2 secant cubes, square cubes. Cubes? Yeah, I wrote this wrong. That's a cube. Secant cubes of x's equals secant tangent. Secant of x, tangent of x, that guy. Minus. Well, now it's minus. This became just minus plus the integral of secant x dx. Secant x, I know, is, and I'm almost done here, is equal to secant x tangent x plus. This guy is the natural log of secant x plus tangent x. I think it's absolute value divided by 2, or I divided by 2 later. Absolute value. So now, forget about the 2. So now, what I'm going to do is, I wanted secant cubed. In the beginning, I wanted to know what this guy was. I didn't know. So now, all I'm going to do is divide everything by 2. Yes, yes. So I'm going to get the integral of secant cubed x equals 1/2 secant tangent plus, I forgot the x's on those, sorry, plus 1/2 natural log